Let's start creating a normal test case. We're going to start with data compare, and we're going to discuss how we do that. So let's say I have a migration project, or maybe this is part of my regular production run itself, where datasets come from a SQL Server and they are pushed into Snowflake. So basically, it's as if data is moving from SQL Server to Snowflake. Heterogeneous in a way, so it's a different system. So now I want to make sure that this transfer, there's no translation, there's no transformation happening, just the transfer of data from one system to the other. I want to make sure that this is valid. So what do we do? Well, we're going with reconciliation because there's a source and there's a target. So let's pick up the source and target. Let's go to JDBC connection. Let's say our source, so we'll call this source table, and I'm picking this up from SQL Server. Right. So I define one of my connections to SQL Server. Now there's Copilot and a lot of things I can do, so I can really go out, with the query specifically. I can do a lot of things with that and really define and use the Copilot for query creation, but we won't get into that right now. Right now I'm working with lift and shift. So I'm just going to drag and drop this table, see if it actually works, do a bit of preview. Seems fine, the data set is loading in correctly. And so this is the object I would like to compare. So this has come into SQL Server. I'm going to push it. I'm not going to push it into production. It's already in production. That has happened. I am here to validate the transfer, validate the migration of that. Very helpful for compliance use cases, very helpful for financial systems where there are any hops where data moves from one system to the other, even from a file to a database. Doing this is one of the best routes out there. All right, so that's it. We have loaded our system. You see the session has begun now. So we're in a live Spark session while we are designing the test case, and this table has been loaded in. All right, what's the next step? Well, we have picked up our source. Let's pick up our target. Now I'm going to do both file and JDBC as well, but for now we'll stick to JDBC. We're going to connect to not Snowflake, let's call it target table. And I want this to be from Snowflake, so I just find my connection. Oh, that's not the one I want. There you go. And here you'll see the dependency is on source table. What this means is that in the diagram, target table comes after source table. Now I don't need this because, well, there's no dependency needed, right? So I just remove it. And now we are running in parallel. So that's something for you to keep in mind while you're creating test cases. Now, again, I know exactly what I want to do. I want my din customer table, drag and drop it. Make sure that the system is working since we're doing this live and everything. Yeah, things look fine, and let's go. Let's run this, and now we are loading in table from Snowflake as well, our target system. So now that we have loaded tables from SQL Server and from Snowflake, the only thing left to do is compare. Now I'll use this time to discuss one very important thing. We are trying to understand things at a microscopic level. There's a lot of automation that the application comes with inherently. So if you're, say, creating reconciliation for 500 objects, this is not the way to do it. So there are wizards for doing that. We are just doing this just so we understand, how exactly this works. In the wizards, all of this process is automated, as you can imagine, using the wizard, and then the test cases are generated and automated. But it's important that an end user understands what's happening behind the scenes, so that if they want to, change something, if they want to apply some transformation, if they want to customize things, which is more likely the case for, say, 10% of test cases. As we know, that those 10% test cases is what cause most of the hassle anyways. So that's why this particular system is created in a templatized manner, so that you can edit things as you create them. All right, source object has been loaded in, target object has also been loaded in. Now let's do data compare. Let's add a component, let's call it data compare right there. So what is this comparison node? Well, it does a full data compare between any two data sets. And I do mean data sets here. This is not just JDBC. I can pick up data sets from, say, file, API. I can process them in Python SQL if I want to, then compare any two data sets. And nothing is off limits here. So I decide source, I decide target. I want it to run after source and target tables. And I also want it to run only if they both have passed. If they haven't passed, don't execute this. Now, there are, again, implications for this based on what you would want. So if this thing fails or if thing has an issue, you might want to automatically raise tickets. Welcome to that. I just want to show that you have a lot of options here in deciding how you would like to run the test case. You have a lot of levers. You have a lot of control over these things. Next, in comparison type, I'm going to enable column-wise mismatches because I want to see exactly which columns are being mismatched in the system. And in the advanced options, automatic data type conversion is ticked by default. So the assumption here is if it's a heterogeneous system, the data types are not going to match. One thing, SQL Server and Snowflake don't really have many data sets that match. There are some columns which just don't exist in the other. So there's going to be some transfer, and that is a source of problems for a lot of migrations as well. So if you would want to, say, automatically convert that string into an integer before comparing it against another integer, you can do that inherently. So that's done by default. If you want that to still catch issues, just untick it. And in the similar vein, you have all the other examples of advanced options as well. It's just there to make sure your life is easier, so to speak. In threshold options, what you see is only in B, and so on. So this is an edge case where you might not want to raise alarms if you're expecting some problem. So in realistic data, say you're working with horrible data, like, yeah, it's realistic, it's horrible. So each refresh, there are some issues, but you have built your pipeline so that it can handle a small percentage of issues and still be fine. So like if there are, say, just a few mismatches, it's okay. You don't want to rerun a pipeline for that. So in that case, if you want to not raise alarms unnecessarily, but still catch issues, you can change these thresholding options. And you'll see this kind of control in every step next moving forward as well. So here you see one of the key problems that comes up, which is that, hey, these column names are not matching. Now, even if the column names are slightly different, the application easily takes care of all of this, because what it does by default is remaps them by name. This is done when we automatically create these test cases in bulk. This is done automatically, so that even if you have different, like, say, column names, which is birth date or birth underscore date, so there are, say, things being added between systems, fuzzy logic is used to define the correlation between them. And of course, if you really want to change things, like, say, here, let's look at the date formats. Here, both of them are in the same date format, but if I wanted to, I can simply convert this to a timestamp as well. I can do this manually. It's not really needed, but the key aspect is you have control over this. You have control over thresholding. You can change the exact column as well that is being mapped. So while most of the stuff is done in an automated fashion, if you want to get into the nitty-gritty details and do it yourself, you have a lot of options here in bulk as well. So now if I click next, it's going to give me a warning. It's going to say, hey, you have not selected a unique key. Are you sure you want to continue without it? So this is optional. The step is optional, but is highly recommended. It's that, how exactly do we distinguish between a mismatch and a missing record? Think about it. We have our primary key as customer key right here, and I'm going to use this to join. I can even use a couple of composite keys here as well. But what do we mean by this? So say between your source and target, you had customer key 5, and between customer key 5, between datasets A and datasets B, what we know is that the name JON John has been, say, misspelled in target. It's JOHN John. By the way, apologies. There's some heavy thunderstorms going on here, so if something goes out, I'll just keep you guys posted on that. But it's going back to what I was saying. Yeah, so basically, if you have, say, an example where there's a source, there's a target, there's a primary key associated 5. In the source, it's JON John, and the target is JOHN John. That's a mismatch. Why is that a mismatch? Because the customer key is the same. However, if you had, say, Lisa and Lisa, the customer name is the same now, but the customer key is different. Now it's 70 and 632. Well, that's an issue, right? You can't really say that the same name is a mismatch, because they are most likely different records. In fact, they might be missing records. And you know this because the unique identifier in that table is the customer key. So that is something that's asked when you create a test case manually. When you automate this entire process, basically when you use a wizard to do this for 500 tables, the application understands, using the JDBC queries and the metadata and the table definition, that what a unique key is, and it takes care of that inherently. But again, if you're doing this for files and DBs, it's kind of important to define that, because as you'll see when I run this particular test case, we're going to segregate our bad records as well into different sections, because again, there's a difference between a mismatch and there's a difference between missing records and how you process them. So we need to do that inherently. So there we go. This particular node runs. It's going to do a data compare between systems. As we see, source table has a 90% match rate. And what it has done is that it has created data sets. This is not just 50 records here. This is a preview of the data set that's running. And we have a data set for the mismatch records. If you remember, I did column-wise mismatches so that I could show you guys exactly what the mismatches are and what they mean in context of a customer key. Because these are all the mismatches between A and B. But only in A is the records which are completely absent in the target. And so this is the distinction between the two.
For further questions, feel free to reach contact@datagaps.com. Request a free demo. Scan the QR code below. Thank you.